Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzuddin bin Muhammad Fazli. My matrix number is CF1800042. So my part at infrastructure is earthwork. So first of all, earthwork is the fundamental concept and practice of earthworks for project for all size, from little work to huge earth construction. It's covered in detail the critical process involved in field clarification, excavation, field material design, field relation, field compaction, field cutting, and embankment stability, providing a knowledge to a quote engineer on this vital issue. So a quote is a very realistic in a construction project. Completing it on time is frequently critical to the overall project's timely completion. A work is in general engineering works built from the movement or processing of portions of the earth's surface that contain soil of unframed rock. So next, earthwork design process. To ensure that the earthwork process is safe and cost effective, the design approach will be applied during site construction. The following is described the earthwork design technique used for both structures. Basically, there are a few steps for earthwork process. First is site clearing and temporary earth drain, next clearing and grubbing, stripping topsoil, cut and fill and proposed level, and lastly for site preparation. This calculation that I was made for cut and fill details. So my construction total area is 70.02 acres. For total cut is 2315.60 cum. For spoil at 20% is 463.12 cum, and a variable field 1085.2.48. On total field is 3362.80 cum. So input field 1510.32 cum, and for access cut is none, nil cum. This is the design and calculation from Excel that I was made. I calculated and I draw to the AutoCAD, and I got this calculation for the cut and fill figure. Next, we go to the earthwork drawing. So this one is a layout boundary layout, AutoCAD boundary layout. So my team is picked on block G. So you can see the layout, the boundaries for the how to I calculate the cut and fill. Next drawing is for the cut section. This one is for the cross section A and cross section B for calculate the cut and fill. Next is for the cross section 1 and cross section 2 for the cut and fill. So what we can see from the for red color is for the cut, and the red color for the fill, and for the blue color is the cut section. Next one is the earthwork construction layout. So this one for the last drawing. You can see the blue is for the temporary hoarding. For the purple color is stockpile storage area and strip trap sediment basin. And for the green at the first door is a wash bay area, And for the yellow is material storage area, for the green equipment storage area. And that's all for me from for a work project. Thank you.
Bismillahirrahmanirrahim, and I will continue the part of designing a drainage. So first of all, what is the objective in designing a drainage? The objective is to transport a stormwater out from the surface of the road at the location proposed. For the introduction, is while constructing a building, the utmost importance must be given to its drainage system, as well from what we have learned in this course. So, the drainage system is an excavated channel or a combination of channel designed to direct runoff away from the construction site or disturbing areas. The drainage system was built in a combination of additional BMP to prevent excessive water inside the working area, as well as to channel the water to a designated area. As for this project, we have been referring to the MASMA second edition and hydrological procedure has P26 to find the parameter in designing a drainage in Sarawak area. So after complete list out all the parameter that was required in to design a drainage, the related calculation, design, taking off and bill of quantity will be prepared. So this is our catchment area, which is located in Institute Kemahiran Islam Sarawak. So by referring to Google Explore, the total catchment area for that area is 11,985 meters square. And this is condition around existing catchment area. And for drainage calculation, we have referring to the MASMA second edition and HP26 for that value for which is for the ARR for Sarawak, we has been referring to HP26, which is especially for Sarawak and Sabah. So for design ARI, we have been choose for 2 years, which is a standard years for development. Next is after determine that value, we need to use a rational method to calculate the peak discharge. So for the value of overland distance and drain distance, we have been determined by referring to our drawing. While for the slope percentage value of reference coefficient and velocity, we have been used for the standard value by referring to the MASMA. So after entering that value, we has been determined that the peak discharge is okay, which is 2.58. And after that, we need to draft a drain section for proposed development. So after we draft the drain section, we have been determined is only have 4. And for the sub area for drain section 1 to 2 and 3 to 4, the value of sub-area is same, which is 270 meter square, and while for drain section 2 to 3 and 4 to 1, the sub-area is 45 meter square. So for the adjustment factors, we have been used for the standard value for that, which is 0.010, and for same with width of drain and surface of drain, we also use a standard value for that parameters. So for the width of drain, we have been used 600 millimeter, and for size of drain is 300 millimeter. And second parameters we need to determine is drain length. For that value, we determine or find from the drawing. And for the width of, for the height, we also use a standard value for that parameters. And after we enter in all the value that need to be changed, we have been determined the for in this design a drainage all will pass. Last but not least is conclusion. For the conclusion, drainage system is a pattern formed by the stream, rivers, and lakes in a particular drainage basin. Rainwater drainage system is very important to properly channel rainwater, which may damage the properties. If the proper system is not installed, when there are heavy rainfall, there may be problems such as water clogging and leaking in the roof, and so on. So for this project, all the drainage design are passed and accepted since the velocity is less than 4 meters per second, and all dimension has been used by referring to the standard mass second addition and hydrological procedure, which is SP26. And lastly this is our drainage layout. So for our drainage layout, we have been provided a detention pond, seal trap, interblocking block, and store pile.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hazila Izni binti Muhammad Hanafiah. My meeting number CF180113. I will present on road. For introduction, a flexible pavement structure maintains intimate contact with and distributes loads to subgrade and depends on aggregate interlocking, particle friction, and cohesion of stability. Thus, the classical flexible pavement includes primarily those pavements that are composed of a series of granular layers topped by a relatively thin, high-quality bituminous wearing surface. JKR design manual on flexible pavement is suitable for the design of road with medium or heavy traffic. The core of the design manual is the thickness design nomograph, which has developed based on H2 design chart for pavement terminal serviceability index. For other values of subgrade CBR, the thickness is determined analytically using Chevron, a multi-layer linear analysis software. The layer of the road will be designed by 4 layers, which consists of surface layer, base course, sub-base course, and subgrade. The design of the road will be indicated is about 10 years because it will be economical. The location of the cross-section and the detailing road design will be shown. For road design calculation, class of road used is U2, initial daily traffic volume ADT 1000, design of live road is for 10 years, percentage of commercial vehicles 50%, annual growth rate 7%, equivalent factor 1.2, subgrade CBR 5%, and rolling terrain. This is the pavement detail of the road. This is road layout that has been designed at construction site. This is road marking and road signage that has been posted at the construction site. And lastly, dimension of cup and scupper for road.
Assalamualaikum and a very good morning. So I will explain about the sewerage part for this project, which is the sewerage system or wastewater collection system. Is a network of the pipes, pumping station, and also appurtenances that convey sewage from its point from origin of the treatment and the disposal. The second point is the sewage treatment is the process of removing contaminants from the wastewater and household sewage water. It includes a physical, biological, and also sometimes a chemical process to remove the pollutants. For this project, were required to design a sewerage system for our project, which is 4-story of Asrama Institute Islam Sarawak, from the originating point to the sewage treatment plant disposal point. So, for the next, population equivalence for our project is as shown at this table, which is for the ground floor, we have 15 units of unit room, which is 2 person were living in per unit. After that, for first floor until the third floor is 18 unit of room. That is total recommended population equivalent is 1, which is as a full time of school, and the total of population equivalent is 138. So the minimum permissible velocity at peak flow is 0.8 meter per second. Maximum velocity of flow is 4.0 meter per second. Average flow rate is 222 liters per capita per day. And type of pipe is a VCP pipe that approved by JPP. Minimum diameter is 225 millimeter. So the design criteria is we suggested for 4 new proposed of manhole, which is the ground level is according to the road level existing, and also the value of depth and invert level of manhole is stated at this table. This is the sewerage analysis that we conclude from the Excel. And the last one is the sewerage layout plan that we propose for our project. Thank you.
Assalamualaikum. My name is Muhammad Fazrul Hafiz bin Suhairi and my matric number is CF180016. Okay, first of all, I would like to present about water articulation for our projects. Basically, water is one of the main supplies needed for one to carry out their daily life. As for the hotel that is to be built, an efficient water supply should be provided. Water supply system can be defined as one system that supply water from the main source of water, such as a water storage or dam, or using a serial number of pipe for the water to reach the destination, so the water can be used for the consumer. Okay, Before any works regarding to water supply system to be implemented or some stage, and there are some stage that need to take into measures, such as first of all surveying work to determine the alignment of the pipe that will be installed into the building. Okay, second, site clearing to prevent any obstacle faced during the work implementation. And third is the excavation work for the water supply component that will be installing underground. And fourth is existing utilities underground that will cross over during work implementation. Next, approval of the material to be used for the project development by the local authority. And the last one is stepping point, where the water supply for the building will take from the main water pipeline for water supply for the building. Next, water articulation, which is several things that we need to do. First of all is a setting up, which is all the setting up of the pipe laying will be conducted by the contractor surveyor. Alignment and grid will be set at 10 meter interval, and all the data will be put in the project drawings. The contractor must preserve any monument, benchmark or survey marker and stake. Any destruction tend to happen, the contractor will bear the cost of the damaged item to be replacement. Okay, next activity is excavation, which is the excavation that will be done will be according to the peg set out by the surveyor. The alignment should be maintained according to the approved drawing, where the run of the pipe trench open up ahead for undistributed area are 600 meter. Other than that, the width of the trench will be determined by the diameter of the by summing up by the coefficient proposed by the JKR. Third activity is a pipe work, which is the contractor must provide the item in use for testing, pipe work testing, and also pressure gauge if the demand. All items to be used must comply with the latest technical specification of local authorities or relevant standard. All items to be used must be included in the drawing. Valve chamber must comply with specification, which is BS EN 124. Hot tapping and the line stopping work must be approved by the local authorities to carry out the activity. Next activity, the external storage tank water. All the water storing tank from the tank reservoir manufacturer to be used must be approved by the local authorities. Type of the tank that can be installed are steel tank with the lining or coating. Second is a cylindrical steel tank, which is a double fault system. And third is polyethylene storage tank, which is a PE storage tank. Next, for design criteria, our group proposed that the type of pipe that we use is mild steel pipe. Okay, the minimum size of pipe is 200 millimeter for the diameter. Okay, then the ODL of the tapping point is 90 meter. For the reduced level is a 43 meter. Okay, the peak factor at 100 meter is a 2.5 average flow spacing apart, which the minimum residual pressure draw off is 10 meter, and minimum pressure at the hydrant is 7 meter. And for the fire flow is one stream at 300 IGPM N. Okay, the roughness of coefficient is 100. Next, the water demand calculation. Okay, for this project is a hostel. Okay, where the occupant is 118, which is from a value that times by the number of room is, which is 69 times by 2. You get 118. So for the average rate water that used for the hostel are 215 liter per day. Okay, which is 118 times by 215. It will get 34,500 liter per day. So in the gallon is 7,588 gallon. Okay, for the hydrant flow, okay, the class is a class B, which is a congested area with the building up to 5 story. Okay, for the average total flow in liter per minute is 2,700. For the spanning meter is 19, A maximum number of the hydrant outlet used simultaneously is 2, which is at 1370 per minute. Okay, for the hydrant flow, which is 2700 divided by 16 second, it will get 45 liter per second. For the total water demand in the apartment, or what I can say is the hostel, okay, the hydrant flow is 1.389 liter per second plus 45 liter per second. It will get 46.389 liter per second. For the peak flow is 2.5 average flow, which is 2.5 times by 1.389, so it will get 3.473 liter per second. Next, for the flow rate and the velocity of water supply for this project, for the area of pipe, the number is 0.014 meter per square, and for the velocity is we get 0.08, okay, which is the maximum velocity in pipe is below than 0.6, so the velocity is okay. Next, for the Reynolds number, okay, from the calculation that we use is we get the Reynolds number is 616 at 6.24, which is 1684 86.24, which is the Reynolds number is below than 2000. This type of flow can be identified as a laminar flow. As for the K, is we can conclude is 1.8. Okay, next is the data for friction loss, minor loss, and head loss that I use, or basically I put it in table. Okay, for the pipe 1, the length of pipe is 14. From the calculation that we get is the friction loss is 0.0117. Then for the minor loss is 0.0067, and for the head loss is 0.0078. For the number pipe of 2, okay, the length of pipe is 72, which the friction loss is 0.0606, so the minor loss is 0.0067, and the head loss is 0.0673. And the last pipe is pipe number 3, which is the length of pipe is 74. Okay, the friction loss is 0.0623, and the minor loss is 0.0067, and the head loss is 0.069. Okay, next, here is our drawing for the water reticulation for this building. Okay, for the SV, it state for the sludge what I mean is sludge valve, and for the H is a fire hydrant, and the I mean is the red number, which is like a T section, or we divided is the bending pipe area. Okay, that's it from me. Thank you. Here is our location for our propose for the pipe system for this building. Thank you.